Good afternoon. My name is Melissa, and I will be your conference operator today. At this time, I would like to welcome everyone to the GlassFish 3.1 Clustering Deep Dive webcast. All lines have been placed on mute to prevent any background noise. If you should need assistance during the call, please press star, then 0, and the operator will come back online to assist you. Thank you. I would now like to turn the call over to Mr. John Klingon. You may begin your conference.
Thank you very much, Melissa. Hi, my name is John Klingon. I'm on the GlassFish Server and Java EE product management team. And before we actually begin the conference, I thought I'd just kind of deliver a note here. And that is, throughout the presentation, feel free to ask questions in the chat window. And when you actually deliver a question, make sure that the Send To drop-down box says everyone, right? So everyone can kind of see the questions and also see the responses. And that way we can share information. Also, if you're on the GlassFish product management team, on the GlassFish product team, whether it's engineering or product management, feel free to identify yourself in the chat window so that other viewers can see, who they can ask questions to. So with that, I'd like to begin the actual presentation here. So this presentation is covering clustering, the GlassFish clustering deep dive. So we're going to get pretty deep into the architecture of clustering and so on. So I'd like to begin with an overview. And with this overview, you may have seen this slide before. This is kind of an introductory slide to GlassFish Server 3.1 as a whole. First, GlassFish Server is the Java EE reference implementation, and in particular, GlassFish Server 3 and 3.1 is a reference implementation for Java EE 6. And it's proven by developers. We currently are on track again for roughly another 10 million downloads this year. And we've gotten a tremendous amount of positive feedback from developers around our ease of use. Of course, they get early access to the latest standards, Java EE 6 in this case. We offer rapid iterative deployment. OSGI modularity, so the app server is actually very lightweight, starts up quickly, uses a minimal amount of resources. But what we're really here today to talk about is some of the production features, which I've highlighted here. And by the way, we're on slide number 4, just so if you want to know if you're up to date. The production features that we're going to be covering today really are around centralized administration and high availability clustering, and those two are relatively tightly coupled. And another nice feature of GlassFish Server is that we're very performant. So GlassFish Server is the fastest open source application server, and that's based on the results that we've delivered to the spec benchmark results, SpecJF Server 2004 in particular. Something else I'd like to point out is that there are multiple distributions of GlassFish Server. There's a commercial distribution named Oracle GlassFish Server, and there's also a open source distribution named GlassFish Server Open Source Edition. And even within those, there's multiple distributions. For example, there's the web profile and then the full distribution as well. There's also a third, which is the the Java EE SDK, which is a developer bundle that includes some tutorials as well and some additional documentation. What I'll be doing throughout this presentation is making sure that you understand which features are available in open source and which features are available only with Oracle GlassFish Server. Some features are only available in the commercial distribution, but the core features such as clustering and centralized administration are available in the open source distributions. And the last point I'd like to bring up is that GlassFish Server and WebLogic actually do share a lot of components, and I know that many of the people on this call are both WebLogic users as well as GlassFish Server users. And today, for example, we share the same JAXB implementation, the same JAXWS implementation, WS atomic transactions, Eclipse Link, and so on. And what you'll see over time is where it makes sense, we'll share additional technologies. For example, our HK2 modular runtime is actually going to be shared with WebLogic. And this doesn't mean that the app servers are converging in any way. It's just where it makes sense, we will be sharing technologies but then we'll also be offering differentiated feature sets over time. Next slide, 7. What's new in GlassFish Server 3.1 clustering? And there is actually quite a bit new relative to GlassFish Server 2.1, which is the last release that actually supported clustering, or 2.1.1 in particular. We've done a lot to improve ease of use. It's actually more flexible in the way we do clustering, more scalable, and I'll be digging into these throughout the presentation here, so you'll be able to understand these in more depth. We definitely offer better performance, better or smarter failover, so that if an instance fails, the amount of time for the cluster to recover from a failure is actually much faster now in GlassFish Server 3.1. And we actually deliver more services that are highly available, and I'll be digging into those as well. So this is just a simple ease of use example, where in the upper left you can basically see this is the installer that we offer. We basically offer a zip file that you can just unzip, or you can use an actual graphical installer. And with the graphical installer, you kind of have some choices about the installation. One is, do you just want to create a server domain? Do you want to also create a standalone instance? Do you want to create a cluster? And that red highlighted box in the upper left shows that in the installer, you can actually create a cluster at an install time. And this is great for evaluating clustering essentially out of the box at its install time. And in the lower right, you see the larger GUI screen that just shows a little bit more detail about the information that you can provide to actually create a cluster. So this is one of those ease of use features that we offer. It's a small incremental improvement, but it's definitely useful for those that are evaluating clustering with GlassFish. Next, I'd like to dig into the management architecture. And to begin with, I'm starting out with GlassFish Server 2.1 management architecture. And I suspect that a lot of people viewing this presentation are very familiar with GlassFish 2.1 clustering. And what I'm going to do here is take you through a step-by-step approach for how we've modified the management architecture as we move to 3.1. So what you see here, for those of you new to GlassFish clustering, is in the middle is essentially the central intelligence of clustering, and that's the Domain Administration Server, also known as the DAS for short. I'll be referring to it as the DAS throughout this presentation. And the DAS basically contains all knowledge of a domain. So domain includes information such as configurations, resource definitions such as connection pools and so on. Understands all the clusters that are defined, all the instances that belong to those clusters, deployed applications, and so on. So it's kind of the centralized repository. And on the left-hand side, what you see are means of gaining access to the administration server, basically to do administration. So that means deploying applications, creating instances, and so on. In the upper left, you see that we have a GUI administration console that existed in GlassFish 2.1. In the middle, on the middle left, you see essentially an IDE, NetBeans, it could be Eclipse, IntelliJ, or so on. So all of those IDEs actually can work with the domain administration server to deploy and undeploy and debug applications. And in the lower left, you see the command line tool. So GlassFish includes the command line tool. If you want to, for example, create automated scripts in production, you can use the command line tool to do that. Now, on the right-hand side, what you see are various nodes which would exist out on, for example, machines out on your network. And those machines host a node agent and multiple instances, well, one or more instances. And the idea here is that when you want to create a cluster, what GlassFish will do is it'll work with a node agent in GlassFish 2.1 to actually instantiate instances. When I create a cluster across multiple hosts, you would basically select multiple node agents, and those node agents would then create those instances and start them. So the node agents are more or less responsible for managing the life cycle of instances, whether it's create, start, stop, or destroy them. And it also acts as a watchdog. So if an instance fails, it will automatically restart it. Now, all of these components basically interact with each other using a JMX API-based API in GlassFish Server 2.1. And that's just an implementation detail. but they do use JMX in 2.1. So as we move toward GlassFish 3.1, one of the things that we've done is we've actually removed the node agent. And the reason we've done this is, as you look at people using virtualized environments, whether it be Oracle technologies or VMware or Xen or whatever, they're expecting a much more dynamic environment where you want to dynamically provision resources and instances, for instance, GlassFish instances, dynamically. And one of the things that we found is that the node agent adds a bit too much structure in that kind of environment, where anytime you wanted to create an instance, you'd also have to create a node agent. So basically, that's one of the reasons that we've removed the node agent from GlassFish 3.1 architecture. It's also a resource that you have to manage. So you actually have to remotely log into a server and install GlassFish and create a node agent, and that just adds additional administration. And also, the node agent consumes host resources. It's actually a separate running process. It doesn't use a lot of resources, but as you consolidate many virtual servers onto perhaps the same physical resource, a physical server, if you think about 20 or 30 virtual machines running on a physical server, then you also have 20 or 30 copies of the node agent running. So it does add up, and so that's another reason why we've looked at removing the node agent in 3.1. So another thing that we've done here, and you see it in the upper right-hand corner with the circle around it, we've leveraged SSH as a means of replacing the node agent. So the DAS, in combination with SSH, basically takes over the role of managing the life cycle of an instance. Now, SSH is a technology that's used to securely log into remote servers. It can also be used to securely copy files to remote hosts and to securely execute remote applications. And so GlassFish actually integrates a Java SSH library directly into the DAS. And whenever you want to start an instance, the domain administration server will actually use SSH to remotely execute, for example, start an instance on a remote node. So that's basically one part of the means of replacing a node agent. Now, SSH is pretty much pre-configured and installed and running in most Unix and Linux environments. And I'll dig into this in a bit more detail in following slides. So now what about the watchdog role that the node agent offered? So what we do with that in GlassFish Server 3.1 is we use platform services. So a platform service we refer to as the operating system service that can manage applications, manage the lifecycle of applications. So in the Windows operating system, you have a Windows service. So you can actually place an instance under a Windows service control such that if an instance fails, Windows will automatically restart it. And on Solaris, the equivalent is the Solaris management facility. And on Linux, we actually use etcr scripts. So when you boot the server or shut down the server, the instances can automatically be started and stopped as well. The next step that we took is we've essentially replaced JMX as the means to communicate between these various components with HTTP and actually HTTPS. Although JMX technology and API still exist for third-party tools, for example, you may want to manage and monitor GlassFish, so we still fully support JMX. But as an internal protocol about how we communicate between the various components of the management architecture, we now use HTTP/HTTPS. And this is much more cloud-friendly and firewall-friendly as well. And if you look at the lower left of this slide, you'll see that there is a box with get and put. That's just my simple way of showing that we have a RESTful API for managing a domain. So if you'd like, as a developer, you could actually add value-add services or programmatically control essentially all aspects of GlassFish using custom logic. So you can write code that actually securely communicates with the domain administration server through a RESTful API. So you can start, stop, configure resources, and so on, all using a RESTful API. That's something new to GlassFish Server 3.1. In terms of clustering. So this is kind of the final slide here that shows it all kind of put together, where with GlassFish Server 3.1, we've reduced complexity because we've reduced the node agent. We've aligned ourselves better for deployment in cloud and virtualized environments. And something else I thought I'd bring up here is that with, just like we did in GlassFish 2.1, if the DAS is unavailable for some reason, perhaps it's a network failure, a hardware failure, or even the DAS itself fails, remote clusters and remote instances continue to run. And when the DAS becomes available, you'll continue to be able to administer your instances and clusters. And I actually have an additional slide on this topic coming up. So I thought I'd dig a little bit more into SSH and how it manages instance lifecycle. So if you want to use centralized administration with GlassFish in a complete context, you'll really want to use SSH. And as I mentioned, Unix and Linux systems pre-ship with SSH installed, and typically the SSH servers are automatically running. Mac OS also ships it. It's just that you actually have to click a checkbox in one of the admin screens to actually start it. So in all of those Unix-based systems, it's pre-installed and in most cases running. With Windows systems, what you'll want to do is install either Cygwin or the MKS developer tools. So those packages offer an SSH server. So we have very detailed documentation, and I'll have links to the documentation later, on how to actually set up and install these in your environment. So Windows users will want to use Cygwin, and we fully support using Cygwin as an SSH server. In terms of SSH, we support public key authentication. So if you want to basically use public-private key authentication, much like Unix users already do, so that you can remotely log into a system without having to provide a password, we fully support that. And we fully support a password-protected private key as well. If you don't want to use public-private keys, we also support using a username and password. So if you provide the username and password, and we can secure the password also, then we support that as well as a way of authenticating using SSH. Now we've also integrated some SSH tooling into GlassFish itself, into the as-admin command. So if you want to set up the public-private key authentication, we provide the as-admin setup SSH command, and it basically takes care of doing the installation, the setup and configuration of SSH, so that once you set it up, for example, the next time if you want to remotely log into a system, you can just type SSH remote hostname, and it'll just log you in without providing a password or prompting you for a password, because you have a trusted relationship. We also have the ability to test connectivity, basically testing your SSH configuration using as-admin ping node SSH. So actually, after you install an SSH-enabled node, you'll be able to ping it and make sure that SSH is set up properly. And last but not least, and this is actually a pretty big feature in GlassFish Server 3.1, and that is, in past versions, you would actually have to FTP or SFTP up the bits to your remote host and install GlassFish. And with GlassFish Server 3.1, you can use the as-admin install node command. And basically, that will provision GlassFish to remote hosts. And that means it'll actually zip up the current installation, copy it to the remote host, and unzip it. All done for you. So this is a nice way of centralized provisioning of GlassFish to remote hosts where you might want to run remote instances or remote instances that participate in clusters. I thought I'd dig in a little bit more in the GlassFish server nodes. So a node in a GlassFish cluster is a logical representation of a host. And if you're an existing GlassFish Server 2.1 user, it's basically a logical representation of what a node agent used to be, right? So there isn't a physical node or process running on a remote host. It's just a logical representation within the DAS configuration. And there's two types of nodes. There's the SSH node, which I've focused on to the most part so far, and this enables full centralized administration, which includes lifecycle management of remote instances. And While we expect nearly all users to use SSH-enabled nodes because it really facilitates centralized administration, it's actually not required. And for those that don't want to use SSH, for perhaps they have extremely secure environments where they may not even let people use SSH, we have what's called config nodes. And with the config node, this enables you to manually manage the instance of the lifecycle of instances. So what that means is if you have what's called a config node, you can log into the remote server and simply say start local instance, and it'll actually start an instance that way. So using config nodes, you actually have to log into each remote system and start an instance manually. Now, to do this, when using config nodes, you'll have to run what's called enable secure admin from the command line. So you see here, as admin, enable secure admin. And what this will do is essentially set up a secure communication path using SSL, for example, between the admin listener running on the DAS and remote commands such as admin running on the local config node. So that's basically required for secure communication. We also support environments where the DAS and the instances can't talk whatsoever. So there may be a need for highly secure environments to have a complete separation of the DAS and remote instances. And what you can do in that case is actually using export sync bundle, as admin export sync bundle, export a configuration, whether it's an instance or a cluster, copy it to a USB drive, bring it to a secured environment, and then import sync bundle, as admin import sync bundle, to actually import that configuration into the local instances. So you can have a completely decoupled environment if you'd like. We think this is extremely rare. Most customers, again, I think will use SSH nodes, but we do support this. And I'd like to also mention that there's a predefined, when you install GlassFish, there's a predefined config node called localhost-domain1, assuming that you've taken kind of the defaults using the installer, which is domain 1. And another recommendation, this isn't a requirement in any way, but I recommend to not mix SSH and config nodes within the same cluster. And the reason is, for example, some commands like start cluster expect all the nodes to be SSH nodes, so that typically with clustering you have all your instances on remote hosts, and your DAS is perhaps on your local host that you're running the command from. When you say start cluster, it's going to want to use SSH to start the cluster on all the remote instances. And if you have some config nodes, those nodes won't be started. So you kind of have to, even after you say start cluster, if you mix config nodes in with your cluster, you'll then have to log into those nodes and actually run start local instance. And as you explode the number of managed clusters in a DAS, it can just kind of be mentally hard to track. So that's the reason why I kind of recommend not to mix SSH and config nodes within a cluster, although technically you can do it. Another area that we've worked on has been the scalability of the domain administration server. And what you see here is basically kind of a soft cut-off point in terms of manageability. We have no hard limit in GlassFish Server 2.1 in terms of the number of instances that can be managed. But basically, as you added more instances, added more resources, deployed more applications, the startup of the DAS became slower, deploying applications became a little bit slower, and pragmatically speaking, kind of on average, again, this isn't a hard limit, it kind of depends on your environment, we kind of cap out around 24, 25 instances. Some customers go higher, some lower, and that's represented in this diagram as 3 8-node clusters. Okay? So a lot of feedback from customers saying we really like the GlassFish team to basically, help us scale more and get more instances and more clusters managed through a single DAS. And that's actually what we've put a lot of effort on. So what you see here is actually 100 instances broken up into 10 node clusters. So we now formally support up to 100 instances in a cluster. 100 instances in manageable by a domain. We actually support up to 10 node high availability clusters. So 10 instance high availability clusters. They can have 10 instances in a cluster. And again, this is not a hard limit. You can deploy more instances. We only formally support up to 100. So if you actually are running the commercial version of GlassFish and you make a support call, we will constrain it to 100 instances. Just from a QA perspective, that's kind of the environment that we're able to test in. So I should also note that you may not be able to run up to 100. So you might have, for example, hardware limitations on the DAS or in your environment that kind of constrain how many instances you'll be able to run. But technically speaking, we actually support up to 100 instances. And we still have a very responsive DAS and very responsively deploy applications. So a lot of effort has been done here on DAS scalability. Okay, the cluster architecture. So I thought I'd dig a little bit here into actual clustering. Mostly what we've talked to up to this point has been around administration, centralized administration. So we've done a lot of work on improving failover. So those of you familiar with GlassFish Server 2.1, the architecture that we had for clustering was essentially if you have multiple instances, when you have multiple instances in a cluster, we kind of had a buddy algorithm where one instance would replicate all of its sessions to another instance. So if the first instance failed, another instance in the cluster would have the replicated session, so you don't lose any data in a failed in an environment where an instance fails. And what we found there is that that instance that contains all of that information in the failed in the case where an instance fails, that backup instance becomes overloaded with traffic and communication because all the other nodes in the cluster, as the cluster kind of repairs itself, it kind of becomes the bottleneck. So what we've done in GlassFish Server 3.1 is we've basically now, instead of allocating a specific instance as being a buddy for providing replicated sessions or kind of sessions that are available in case of a failover, we now spread that across all other instances in a cluster. So if an instance fails, the load in a failed environment is spread across all instances in the cluster. So it's actually a much smarter failover. And I should also mention that another thing that we've done is to quickly determine which instance has the secondary or the backup data, backup session, we use what's called a consistent hashing algorithm. So you can take the session ID and put it through the consistent hashing algorithm, and it'll come back with which instance that is running on. So, for example, our load balancer plugin immediately takes advantage of this information. So when a user connects to the load balancer to get to their session, and the load balancer recognizes that a node has failed, it can immediately fail over to the instance that contains the backed up session data. And I'll show you that in detail here in a second. And I thought I'd throw in this tidbit here in terms of troubleshooting. GlassFish Server currently does require multicast, not in a failover scenario, but just to understand which instances are available in the cluster. This is kind of how they determine which instances are available and not available. We use multicast to do that. And we had some customers that might have trouble determining, for instance, what the problem was in terms of how come my sessions are not failing over. And so we've added the asadmin validate multicast command. And what you do is you run this command on two instances within your cluster on separate machines, and they will basically send out broadcasts. And you should see on both sides messages being exchanged between these validate multicast commands running on the two hosts. If you don't see that, then from a GlassFish perspective, multicast is not working properly. So it could be a configuration issue somewhere in your software environment, or it could be a configuration issue within your network, because some IT departments might disable multicast. Okay, so this is an example of actually failing over. So as you can see on first request, the load balancer is going to pick an instance to actually handle an HTTP request. And we basically provide two algorithms for selecting, or two load balancing algorithms. The first is simple round robin. Every request that the load balancer gets, it'll simply deliver to the next instance in line. So instance 1, 2, 3, 4, and then it'll fall back on the 5th request back to instance 1 again. We also have weighted round robin, and that's useful for environments where you might have servers that have different capabilities in terms of resources. So one server might have more RAM and CPUs than another. You can actually weight more requests to the more capable server and less requests to the less capable server. So in this case, the web server points the first request at instance 1. Now, as soon as that happens and a session is established, what the servlet is going to do, or GlassFish is going to do, is it's going to pick another instance in the environment to host replicated session information. So if you've enabled a high availability cluster, and I'll show that here in a few slides, then it'll actually create a backup replicated. It'll replicate that data in another instance. So in this case, GlassFish just selects instance 2. So at this point, any data that you have in your HTTP session is in 2 places. In this case, instance 1 and instance 2. Now, what's nice about one architecture is we actually store that information in terms of where the replica is in the session cookie. So the web server actually now knows exactly by introspecting that cookie where the replicated session is. So for instance, if that instance dies, the web server can automatically, again, by introspecting the cookie and looking at one of the attributes, redirect the instance directly to where that replicated session is. So in this case, instance 2 can immediately handle the session because the data is local. For other load balancers, if you have a hardware load balancer or ModJK, which we also support, by the way, then that session might actually end up, that request might not fail directly over to instance 2. It might go over to instance 4, in which case that instance will have to use that hashing algorithm to find out where that data is and then request that data. So it's an actual extra step. The nice thing about using the load balancer that we provide is it'll actually fail over directly to this instance that's hosting the replicated session. And after it goes to the replicated session, the next thing it's going to do is say, okay, I was a replicated session, the backup essentially. Now I'm the primary, so I'm going to have to go off and allocate a new replica. And so that's what you see here is in a failure scenario, when the request goes to the backup instance, that becomes the primary, and then it'll request essentially a new replica. So you'll always have, more or less always have a primary and a backup session, a copy of your data. Another area where we worked on performance is in performance. So I've mentioned before that one of the problems we had as you scaled out your DAS in terms of adding more instances and resources and applications is the startup time. So we've done a lot of engineering work around optimizing how we start up the DAS, how we start up instances, and so on. So for example, one simple thing is we now use stacks instead of a DOM parser for domain.xml, right? And lots of other optimizations as well. We also now use, in GlassFish 2.1, we use Juxta peer-to-peer technology as our group management protocol for determining which instances belong to a group, but we also used it as an implementation of replicating data between nodes. And we've essentially replaced that now in GlassFish Server 3.1 with Grizzly, which is an NIO-based HTTP listener or listener in general. And by doing that and using some custom logic, instances that are now running within a cluster run up to 34% faster than instances running in a GlassFish Server 2.1 cluster. Right? So simply by using GlassFish Server 3.1, you can get up to a 34% faster performance relative to GlassFish Server 2.1. And I've already mentioned faster failover. Because we use the consistent hashing algorithm, we always know exactly which instance hosts replicated or backed up data, and the load balancer is able to take advantage of that information. Okay. Next, slide here is on deployment application. I suspect many of you familiar with GlassFish know how to do this, but for those of you new to GlassFish, I thought I would show this. You can actually deploy an application using the web console, and that's what's in the top half of the screen. And I thought I would show specifically in the red box that if you want high availability to be enabled, if you want sessions to fail over, such that if you have a shopping cart and the instance hosting that shopping cart fails and you still want the shopping cart data to be available, you'll have to actually select the checkbox availability enabled. Otherwise, you'll have service availability where the application is available on all the nodes, but you wouldn't have session replication. So if you want session availability, data availability, select that checkbox. And the command line equivalent of that is as admin deploy, and you'll use the -- availability enabled equals true option to deploying an application. And I should also mention that in your web XML, there's an XML element called distributable that you'll also want to enable for your web application, and that's basic Java EE specification stuff, and it's also in the GlassFish documentation. So now I'd like to cover some new services and tools that are available. Highly available web services. So new to GlassFish Server 3.1 is we bundle Metro, which is a web services stack, Metro 2.1. And this is, for many of the services, high availability aware. So reliable messaging, secure conversation, security nonce manager, stateful web services, all of these web services features are now high availability enabled. And there's no configuration that you have to do. Basically all you do is, as I mentioned in the previous slide, just make sure that availability is enabled and you kind of get that automatically for web services. I've got some links here at the bottom. Don't worry about those. In particular, the replay will have these links. But metro.java.net is the top level page for the Metro Web Services bundle. And from there, you can find out more about high availability web services. Another new highly available service is the embedded JMS broker. So GlassFish Server 3.1 embeds, well, the open source version, GlassFish Server Open Source Edition embeds OpenMQ 4.5, and Oracle GlassFish Server embeds Oracle GlassFish MQ 4.5. And the only difference really is the licensing and the branding. Technically and functionally, they're equivalent. We've always had the capability to run an external standalone broker in its own process and an embedded broker. What's new in this release is the embedded broker can actually run in a cluster and be cluster aware. So in GlassFish Server 2.1, that was not the case. So we now have the ability to offer service and data availability for an embedded MQ broker. So it's nice now that you can actually have a high availability environment, but not have to run separate brokers and separate JVMs. You can just run them in the same JVM that's running GlassFish Server. This is the default mode for both standalone instances and for clusters. This also supports dynamic cluster changes. So as you add instances to a cluster, and I should mention that with GlassFish, you can dynamically add or remove cluster instances on the fly, and it all kind of figures it out. GlassFish Server kind of figures out the shape change of the cluster. This is supported with the embedded GMS broker as well. And I should also mention that with the GMS broker, we lazily load it. So just because it's embedded doesn't mean it's running. So if your applications do not require GMS, we actually don't start the GMS broker. This is one of the benefits we have from the modular OSGI-based infrastructure that GlassFish runs on. However, if you do have an application, for example, that has a message-driven bean, and you deploy that application, then the GMS broker will dynamically be started. There's nothing you have to do. It'll just start on its own. So that's kind of a nice feature. A new tool that we have, and this tool is only available with Oracle GlassFish Server. This is not available with GlassFish Server Open Source Edition, and that's the Load Balancer Configurator. So basically, it's a GUI to help you install the load balancer. And this is supported with the Oracle iPlanet Web Server, Microsoft IIS, Apache, and the Oracle HTTP server. So basically, when you run this installer, it'll ask you a set of questions and automatically update the configuration of the web server to handle the load balancer plugin. So that's kind of a nice feature. And again, with this load balancer, it does support smart failover. So it'll automatically, if when an instance fails, it knows exactly which instance to fail over to that has the backed up session data. Now with this configuration tool, there's a GUI. So the first time you run this, you'll fill in the information, and you have the option of saving that information to a text file, kind of like a template. And then if you have a web server farm, you can rerun this tool in kind of a text-only mode and reference that saved template and basically use provisioning tools to automate that installation across a web server farm. So you don't have to run the GUI to install the web server plugin. That's a nice feature. And again, you can use hardware load balancers with GlassFish. We officially also support ModJK, but it doesn't have the smart failover feature. DAS backup and recovery. Since we're talking about clusters and centralized administration, a nice feature that GlassFish has is we have the ability to back up a DAS configuration. So if the DAS fails, again, it could be a hardware failure, or the DAS, perhaps it gets corrupted for some reason, disk errors or something. Then you can actually bring up the DAS on a separate host. And basically we refer to that as restoring a DAS. And you can also have multiple backup snapshots. So you can, basically back up on some regular basis if you'd like. And that core functionality is actually available in GlassFish Server Open Source Edition. However, if you have Oracle GlassFish Server, we added some additional features where you can schedule backups. And out of the default, we have 3 predefined configurations, daily, weekly, and monthly schedules. And you can create your own. Maybe it's hourly, it's bi-monthly or whatever. And you can set up multiple schedules so you can do full backups of the full domain on some coarse-grained basis, and then just the config directory, which contains just the configuration of the domain on perhaps a more fine-grained basis, maybe weekly or hourly, or depends how paranoid you are. And you can also limit the number of backups. The default is 25. And another important differentiator with using Oracle GlassFish Server is that you can actually back up a live running DAS, whereas if you're running GlassFish Server Open Source Edition, you basically have to shut down the DAS to do a backup, so it's in a known and consistent state. And we kind of take care of that. There's some features that we have in the commercial version that helps you with having a consistent view of the domain during a backup. Okay, another feature that we offer, or will offer soon in the first half here of 2011, calendar year 2011, is what's called Active Cache for GlassFish. And this is a feature that's similar to the one offered with Active Cache that's available at WebLogic Server. And this is a feature that will only be available with Oracle GlassFish Server. And essentially what this does is we replace the HTTP session state. Instead of using in-memory session replication, where the sessions are stored in the same JVM as the GlassFish server. Using Coherence Web, we actually use Coherence Web as kind of a replacement for storing HTTP session state. And this is nice because it provides a more scalable model. So your HTTP sessions that are stored in Coherence are actually stored in their own logical tier. So that means they could be stored in separate JVMs on the same physical servers as application server instances, or you can run them separately on their own physical servers as well. And this enables you to create some flexible deployment models in terms of how you want to best scale to meet your scalability needs, because the business logic and the state replication are completely decoupled in this model. And a nice feature that Active Cache for GlassFish and Coherence Web offer is the ability for flexible scope configuration. And that means different applications, perhaps even across different clusters, can share the same session state. And this is useful, for example, if you're one company that has multiple websites that you manage, you can actually share the session state through different applications and different clusters using this model. So it's actually really nice. And there's also flexible locking models optimistic locking for how you gain access to session information. Member locking, so only one node in the cluster has access to a session at a time. Thread level locking is another fine-grained model. So there's lots of details in terms of this architecture. And I want to point out a screencast that Adam Leftick, a fellow product manager on the GlassFish team, has created. Just Google Active Cache for GlassFish, or you can look at the link here, and he digs pretty deep into how you can leverage Active Cache for GlassFish to scale your environment. And with this, I'd like to kind of point to what's really the final slide, and this is where you can get more information. So a lot of what I've discussed here, we actually have screencasts that have been created by product management, by the engineers that have actually created the features at the YouTube. So if you go to youtube.com/GlassFish videos, we've got quite a few screencasts going over the various incremental features or major features that have been delivered in GlassFish Server 3.1. You can also look at blogs.sun.com/theaquarium. That's the blog that we discuss all things GlassFish. And a lot of these features are discussed here, and there's links not only to the videos, but also off to blog entries that again, product management and product team as a whole engineers have created. And this is the first release where we've actually split documentation. So now we have commercial documentation that's available on docs.oracle.com. We also have open source documentation that covers the features available in GlassFish Server Open Source Edition, and that's available on glassfish.org. And the reason we've done this, and you kind of might understand this based on some of the features that we offer in, I kind of discussed previously, and that is GlassFish Server Open Source Edition offers a rich set of features, and then Oracle GlassFish Server, we have some features that are only available with Oracle GlassFish Server. So if you read the commercial documentation, you'll have documentation on those features. If you read the open source documentation, you won't see those features discussed. It's just to make a clear delineation so we don't confuse our user base. So if you're using the open source edition of GlassFish Server, please use the open source documentation. If you're using the commercial version of the application server, then use the commercial documentation. And anything that's in that documentation is what we formally support as a commercial product. And go ahead and move on to one more slide here, basically saying thank you all for attending. At this point, what we'll do is I'll see if I can look at the chat window and perhaps cover some of the questions that have been prompted to the chat window. And I apologize because I haven't actually had a chance to look at the questions during the presentation. I was actually delivering the presentation. And so I'll take a look here. If you have a question that may not have been answered, feel free to ask it in the chat window, and I'll be happy to respond, or perhaps one of the GlassFish product team members can also respond and ask you something to get me to the point. So here's a question: can you use the load balancer with the open source edition? The answer is technically yes. However, legally, no. So the load balancer plugin that we ship with that load balancer configurator is actually falls under a commercial license. So you can, under an evaluation license, go ahead and download Oracle GlassFish Server and the load balancer configurator and try it out. Try all the features that are available in the commercial version. However, if you decide that you want to use the open source edition for whatever reason, then you'll basically have to use ModJK or some other open source or third-party load balancer. So then what is the difference from the commercial version? I think I'll need a more specific question. I apologize. But basically the commercial version gives you the load balancer plugin and configurator that you can use inside of, again, Apache, the iPlanet web server, and the Oracle HTTP server, and Microsoft IIS. Okay. The commercial versions also of GlassFish, Oracle GlassFish Server, also offers support, offers patches, DES backup and recovery I've mentioned, Oracle We also offer the Active Cache for GlassFish. If you're an Oracle customer and you would like to use Oracle Single Sign-On Solution, Oracle Access Manager, we provide some bindings to Oracle Access Manager. That's another differentiator between Oracle GlassFish Server and the open source version. So that's just kind of a brief overview of some of the differences between the commercial version and the open source version. And this sounds like a very good screencast I should create. So I think I'll have to create a screencast showing the differentiations between the open source edition and the commercial version, just so it's very clear to people. Any other questions, perhaps, on the chat line? We've got about 5 more minutes to take questions. Yes, very good point, Arun. So if you have questions that after this webinar is concluded, then there's a couple of places you can go. As Arun points out, we have a GlassFish Twitter tag, so feel free to Twitter to @GlassFish any questions related to GlassFish clustering or not, right? And we also have a very active user forum. So if you go to glassfish.org, and on the left-hand side, you'll see links to the GlassFish forums and the mailing lists. All the folks on the product team essentially listen to those forums and aliases. So we try our best to respond, and if we don't, and the community will. In fact, sometimes the community beats us to the punch anyway. So it's pretty vibrant. So any other questions that you might have regarding GlassFish clustering? Okay, at this point, I think what we'll do is conclude the webinar. Thank you very much for attending. As you can see here, take a look at our future webinars at glassfish.org/webinars, where we keep a list of kind of what's coming down the pipe. We hope you join future webinars. Thank you very much. And at this point, I think I'd like to transfer control back to Melissa.
Thank you for joining today's conference call. You may now disconnect your line.